I'm Cameron. I'm the product lead for the Go programming language at Google. I don't have all the answers, but I try to find them. In this presentation, though, I'm going to tell you a bit about the Go team's vision for the future of software engineering and what we're building to get us there. Before we do that, I'll tell you a little bit about myself for a second. I've been on the Go team for a little over 5 years now, and I've been its product lead since 2022. As I mentioned, this GopherCon is extra special, not least because New York is where most of the Go team sits. And so you can find us here this week at our booth or in the hallways. We'd all love to chat, so don't hesitate to approach us. I myself have lived in New York for 19 years, which is like a badge of honor. New York can be a hard place to live, and sometimes I think I've had enough, but whenever I go anywhere else, I'm reminded why I stay. New York is this place of pragmatic energy, authenticity, and this unique brand of kindness. In the next 20 minutes, I'm going to talk about what the Go team sees happening in software engineering and how that impacts the work we do. It's probably no surprise that AI is going to be a big part of that. First, we'll touch on what we see happening to software engineering generally, how AI impacts how we build. Second, we'll talk about Go. Our founding principles, our legacy of leadership, and how the evolution of software engineering intersects with our principles. Finally, we'll talk about what we're doing about it, a broad description of what's ahead. Now, before we get started, I want to acknowledge that many of you are probably really tired of AI. There's a lot of hype and snake oil, a lot of misconceptions around what it can do, and I appreciate that that's really frustrating. I think this story is true. There's some big voices in the industry that have these sort of bombastic things to say. Jensen Huang says that soon nobody will have to program, that the miracle of AI is that the programming language is human. Elon Musk says we won't need to write code and we won't need software engineers. Then there's other voices, like Google's own Sundar Pichai. They've got a different take. They say that AI will empower developers. Sundar said something more recently about envisioning that we'll need to hire many more software engineers because the opportunity space is expanding. So, yes, developers are more productive, but that just makes their jobs more important. Satya Nadella said something similar. He says that AI amplifies what you do. The developer is the pilot, the AI is the co-pilot. And then there's some practical opinions that I think we can all resonate with. This is the one I relate to the most. I want AI to do my laundry and dishes so that I can do art and writing. In many of our internal tools and processes on the Go team, we've sought to identify the laundry and dishes in software engineering so that we can delegate it to AI. And then aside from what people say, there's also the data. Most engineers say they're using AI a lot. Nearly half told the Stack Overflow developer survey this year that they use AI tools daily. So there's probably something there, even if the hype can sometimes overshadow the virtue. But I don't want to ignore this cohort either. I'm sure some portion of these respondents actually don't have a use for AI, and that's what they mean when they say they don't plan to use it. But I'm also pretty sure that a significant portion of these respondents think that AI is bad. And I just want to say that I see you. The Go team sees you, and we're committed to doing our level best to make sure that what we build is grounded in advancing the same core principles that we've always sought to advance, not the hype or the bombastic rhetoric. So all of that said, here's what we've observed and what is a core theme for the rest of this presentation. When it comes to developer tools and programming languages, programming language platforms like Go, AI and humans have surprisingly similar needs. Clearly, engineering will evolve as it always has, and as it evolves, developer tools like Go will also evolve. For our part, Go will continue to provide the tools and capabilities that make both humans and AI productive and all workloads production ready. So let's dig into it. First, let's talk about software engineering. And the first thing we should do with that is define what software engineering means. Russ, our former TL, who's in the audience, writes that software engineering is what happens to programming when you add time and other programmers, which is a riff on an original idea by our former Google colleague, Titus Winters, whose phrasing was, software engineering is programming integrated over time. The significance of this definition is in how software engineering is distinguished from programming. Where programming is about solving a problem by writing code and then running it, software engineering is the act of collaborating with others to design and implement a durable system that evolves over time. So programming is a part of that, but it's just a part. As we'll discuss in the sections that follow, Go's principal objective is and always has been to serve the whole of software engineering, not just the programming part. So how does AI change any of this? Well, let's walk through how we see AI show up in software engineering today. So we started with predictive text, just an extension of traditional IDE autocomplete with code suggestions. We get this with tools like Copilot or Cursor. The next step was conversational interfaces in the IDE, tools to chat with your code. This sort of functionality came in standalone chat interfaces like ChatGPT and Claude, but also in the same tools and plugins we use for predictive text, again, like Copilot or Cursor. And more recently, we've seen what I'm loosely calling coding agents. And these are often CLI interfaces with a REPL and where the context is the entire project. Some examples are Claude Code and Gemini CLI. And we're also seeing agents all across the whole software development lifecycle. These are often autonomous services that run asynchronously, just fire and forget. Some examples are Google Joules and Copilot Agent. And this timeline of evolution tracks how developers today say they use AI. So from the Stack Overflow survey, we see that the #1 use case for AI is writing code. The next highest ranked use cases are a lot of tasks that are related to learning, like when you're chatting with your code. And finally, we see the stuff in the rest of the SDLC. Code review, creating and maintaining documentation, testing code. Only 10% of these respondents said they used AI for deployment and monitoring, compared to nearly 60% who said they use it to write code. Which has led to this interesting phase where the AI is used disproportionately over the software development lifecycle, which creates a bottleneck in existing processes. Because AI reduces the cost of producing code, there's a lot more code being produced. With a lot more code being produced, there's a lot more code to review. But we don't use AI to review code as much as we do to write code, so developers are spending more time reviewing code than they used to. That's the current imbalance in software engineering in the AI era. AI is doing the art and writing and leaving us to do the laundry and dishes. This all leads to the takeaway of this section, which is that the current state of AI-powered development has changed the roles of engineers and programming languages in at least 3 ways. First, AI and agents are doing more code generation and editing, whether through code suggestions or in REPLs or in autonomous agents. This makes rapid iteration a component of agentic productivity. Agents are more successful when they have a fast dev loop. Second, the growing imbalance between the costs of code generation and code validation mean all the stuff that make code easy to understand and reason about is even more important. Readability, type checking, stylistic consistency, easy concurrency. And third, ecosystem. So as we'll discuss later, ecosystem is what makes a language. As AI chooses more dependencies, including tools, libraries, and services, we need tools and signals that ensure the AI's choices are secure, reliable, efficient, trustworthy, and well-maintained. Next, let's talk Go. As Rob wrote back in 2012, Go was designed by and for people who write, read, debug, and maintain large software systems. Go is about language design in the service of software engineering. And language design in service of software engineering actually requires not just a language, but a platform built for software engineering. That meant being opinionated so whole teams could structure, format, and test their code in the same way. That meant promising that the code you wrote today would not only still work in 10 years, but would still be good code in 10 years. And over time, it became clear that the service of software engineering required not just a language and a platform, but also an ecosystem built for software engineering. That meant building a global system for software dependencies that could scale with your teams. And as security became increasingly foundational to software engineering required not just a language and a platform and an ecosystem, but one with security woven through it. Go is a platform in the service of software engineering. Software engineering is what happens to programming when you add time and other programmers. And here's the thing. Increasingly, AI is a teammate and benefits from many of the same tools and platform features as you and me. This author, Thomas Pachek, alludes to this. He says, "I work mostly in Go. I'm confident the designers of the Go programming language didn't set out to produce the most LLM legible language in the industry. They succeeded nonetheless. Go has just enough type safety, an extensive standard library, and a culture that prizes often repetitive idioms. LLMs kick ass generating it." The things Thomas called out together make for code that is easier to generate and validate. Type safety catches errors early. An extensive standard library promotes consistency and security. Repetitive idioms create clarity and consistency. This all makes it so that developers can iterate on AI-generated Go code with greater speed and confidence. These things, along with other things, like a fast dev loop, easy concurrency, secure defaults, and simple readable code, all stem from our founding design principles in service of software engineering. Because AI benefits from the same things as you and me, these things make the AI better and make for better generated code that is easier to validate. And then there's the ecosystem. As I said earlier, the ecosystem is what makes it all. Because Go is a language platform, we have two more opportunities to improve the quality and validation of AI-generated code. First, Go's end-to-end approach, the fact that Go is a platform in service of software engineering, gives the AI tools and resources throughout the software development lifecycle. This includes things like our static and dynamic checkers, our vulnerability management system, our build tools, our libraries, our language server, and all the other things that we provide out of the box as part of the Go language platform. AI can use these tools just as humans do to generate more reliable, more efficient, and more secure code. And humans can validate that code faster and with more confidence. Second, the Go platform can also derive all sorts of quality signals from the ecosystem. So this includes things like vulnerability data, usage and trust signals, and combinations that can help both AI and developers assess the quality of libraries so that they choose dependencies that are better maintained, more reliable, more secure, and more trustworthy. And that brings us to the title of the talk. What's next? Go is famously productive and production ready. And when we think ahead, we usually consider how any proposed work that we're doing furthers one or other of these objectives. Go is productive because it's easy to learn and maintain and scale across teams. And Go is production ready because it's reliable, efficient, stable, and secure. So let's see how we plan to hit each of those objectives next. As AI redefines productivity, we see a few big initiatives. First, there's what we call the stuck in the past problem. Because we train LLMs on data that exists in a specific point in time, LLMs are more likely to generate code that existed before that point in time. And this can leave out new products, new features, new APIs. To help address this problem, both on an individual developer and ecosystem-wide level, we're building modernizers that identify old idioms, method signatures, APIs, and more, and replace them with their modern equivalents. This benefits individual code bases by making it easy to rewrite old code to take advantage of new features. But more importantly, it pulls the whole ecosystem forward, which increases the rate at which new features can propagate in libraries and in the open source code that trains LLMs. Alan from the Go Tools team has a talk about this at 2:25 this afternoon. Second, as we've established, AI can benefit from the same tools as you and me. In order to make it possible for AI to effectively use tools written in Go, including the entirety of the Go platform and its toolchain, we're building an official MCP SDK. You may have seen the experimental MCP server in Go Please, which allows Go Please to expose some of its functionality to AI assistants as MCP tools. Katie Hockman, who used to be on the Go Tools team, has a talk on MCP tomorrow at 11:35. And third, we want to shift left as much as we can with our quality and security signals. As LLMs choose more of our dependencies, the sooner we can get things like vulnerability info in front of the LLM, the better. Which leads to another observation about AI and software engineering. Go's ecosystem has always been this flywheel that powers developer success. The more capable and higher quality the ecosystem, the more developers leverage Go and invest in it themselves, which draws more developers and more developer success, and so on. Now, with AI, this flywheel spins faster. So let's imagine that we get better AI assistants and agents because they leverage the best tools and resources from the Go ecosystem. This leads to more successful developers because they're able to use these better AI assistants and agents and have an overall better developer experience. More successful developers create more Go workloads, which draws more Go developers to work on those workloads. More Go developers mean more developers who invest in the Go ecosystem, either through their jobs or through personal contributions, including open source code, documentation, samples, and a variety of ecosystem signals. This improved ecosystem, in turn, is available to AI, for example, through MCP, which gives us better AI assistants and agents, and so on. The second big area we're thinking about is production readiness, where we want to be sure that Go developers can build reliable, secure, production-ready AI applications and services, the same way we've enabled non-AI applications and services in the past. Before anything else, the biggest takeaway here is that it turns out most AI applications are cloud applications that make high-performance API calls. And this is exactly what Go has always been extremely good at. Again, our focus on software engineering, which includes a focus on enabling modern software engineering architectures and environments, pays dividends. But there are AI-specific things we need to complete the circuit, like the SDKs that enable AI applications, including MCP, but also things like the Agent Development Kit, or ADK, and the Agent-to-Agent Protocol, or A2A. There are also some things that are not AI-specific, but which benefit AI infrastructure. SIMD, which we're working on now, and we're targeting for Go 126 in February, benefits all kinds of high-performance computing, and it also happens to enable writing high-performance vector databases in pure Go. And more generally, we want to keep doing the same things we've always done, make Go faster and better. As hardware evolves, we're evolving the runtime with it. So this includes initiatives like the green tea garbage collector, introduced behind an experimental flag in Go 125, that scales better across NUMA architectures and the many CPU systems that are becoming more prevalent. Michael from the Go core team has a talk on green tea tomorrow at 3:45. So that's how we're thinking of the next frontier. The same principles adapted to evolving engineering needs, and we're pretty confident in this approach. Serving software engineering has always been Go's primary objective, and it's worked well. But we also look to our users too, and so far, so good. We consistently see really high customer satisfaction in our surveys, levels practically unheard of in the industry. We also see remarkable growth in adoption. In the last Stack Overflow survey, 17.5% of professional developers said they used Go, up from 14% last year and 9% 5 years ago. And this proportional growth is happening at a time when the sheer number of developers is also rapidly increasing. But while the developer population at large grows, Go is one of only 2 languages that grows faster, meaning we're targeting the right use cases, providing the right value, and growing for reasons that go beyond that larger growth in software engineering. Finally, we're seeing Go used all over the internet. Late last year, Cloudflare reported that Go is now the most popular choice for API clients. This is a huge jump from the previous year, where Node was #1 and had nearly double the number of API calls as Go. A really remarkable increase for Go and an important milestone in the kind of services for which we know Go is best in class. Which leads me to you, the Go community. As I said earlier, Go's ecosystem is what makes Go what it is. The language design, the platform, the focus on software engineering, and the problems for which we solve, they're all built on top of Go's ecosystem and the community behind it. There are hundreds of thousands of Gophers around the world who meet up. They come to conferences like this because they love Go. And there are thousands of Gophers who contribute to open source, write tutorials and samples, or contribute to the Go project itself. These contributions are what make Go succeed now and in the future. More open source helps train models, making Go work better with AI in a world where more developers choose languages that work well with AI. More quality libraries help humans and AI choose better dependencies. Samples, documentation, and how-to guides help Go developers productively experiment and build AI applications. Contributions to the Go project keep Go productive and performant as hardware evolves. So, I started this talk by joking about my complicated relationship with New York City. I said the reason I stay, the reason it feels like home, is because of the people, the unique combination of kindness, authenticity, and pragmatic energy that makes this city work. Looking out at all of you, I really feel the exact same way. Kindness, authenticity, pragmatic energy. The future of software is complex, and it won't always be easy. But building it with this community is what makes it feel like home. The reality is that the future of Go in the AI era will be built not just by the Go team, but by all of us. Let's have a fantastic conference, and thank you.